Welcome back yet again. Here we go. We're going to be looking at working with variables. And so it's all going to be about simplifying algebraic expressions with our big two tools are combining like terms and then different versions of the distributive property. And so we'll start with combining like terms. What do I mean by like terms? Same variables, same powers. So here are three non-examples of like terms. Variables are different, or variables are the same, but if they're different powers, still not like terms. And don't get tricked by something like this. xy squared and x squared y look similar, but they are not like terms. 2x and negative 3x are like terms. 5x y squared and 6x y squared are like terms. So let's look real quick and let's combine some like terms. 2x and 5x. Well, 2 of something and 5 of the same thing make 7 of that thing. And so 2x and 5x is 7x. Here we have negative 7y plus 18y plus 3y. These are all in terms of y, so they're all like terms. We could do it in pieces. That makes 11y plus 3y, which makes 14y. This one's maybe the sort of trickiest so far. We have x squared in this parentheses and x squared in this parentheses plus 5x minus 2x over here minus 7 plus 1. And then these two pieces are kind of grouped into parentheses and are being added together. And so an x squared and an x squared would make 2x squared. 5x plus negative 2x. So if you have 5 of something and take 2 away, there'd be 3 left. So 2x squared plus 3x. And then negative 7 plus 1 would be negative 6. If you had trouble with this in Algebra 1, and something that you might want to do, a sort of different way to work the problem, here it's an addition problem. Let's go ahead and just line things up. X squared plus 5x minus 7, x squared minus 2x plus 1. And then since we line things up, you can just go down the column. Something and the same thing added together are 2 of that thing, so 2x squared. 5 of something take away 2 of that thing leaves you 3 of that thing, so 3x. And then negative 7 plus 1 would make minus 6. So if you're really comfortable with the idea of combining like terms, you might be able to just sort of look at this problem and put it all together all at once. If you have a little more trouble with these, I would strongly encourage you to maybe line things up into nice, neat columns and then add them together. This is similar to elementary school. If you had a problem like 113 plus 72, you might start it by rewriting the problem so that place values all lined up, and then you just go down the columns. So this kind of reminds you of maybe place value. Alright, a couple more combining like terms problems. This one's sort of the trickiest because there's a lot of different variables running around. There's a couple different sets of parentheses. So I'm just going to go ahead and line this one up as I go and then try to combine things. So 3xy minus 5z. These parentheses didn't actually really do anything because I can't actually combine these together. This set of parentheses, however, has got a subtraction in front of it, so we've got to be a little more careful. So this z would actually be a minus z, which I'm going to line up right there, minus 4xy, which I've already got some xy's, so I would line it up right there. And then I'll treat these two pieces kind of together, even though they didn't have parentheses around them. I could add them. I've got a plus 7z and a minus 2x. Well, I don't have anything yet that's just an x, so I'm going to make a new column. And so what's our grand total here? You would owe me an xy. Negative 5 minus 1 is negative 6. Negative, put a 1 right there if we like. So negative 6 plus 7 is positive 1. So plus z or plus 1z. And there's nothing to combine this with, so we just write it down. And then so it's negative xy plus z minus 2x. Or the opposite of xy plus z minus 2x. And the order these three things are in when you got your final answer might be slightly different, and that's okay. It wouldn't be the end of the world. Alright, for this last problem, let's study it up here. 8x squared y minus xy squared plus 3. Okay, so this is the only number. And let's see, x squared y, xy squared. Uh-oh. These are not like terms, and so there is no like terms in this problem. This problem is already simplified. I'm not sure. That kind of looks a little sloppy. Or I tried to write it in cursive. I might have two eyes there. I don't know. But I think you get the idea. Alright. So the other half of this lesson, or other 2/3, since the lesson's I think a little bit more about distributive property, is the idea that you can use the distributive property to multiply algebraic expressions. And so you have, a times b plus c is ab plus ac. A lot of you probably remember drawing the arrows. And it doesn't matter if there's two things in the parentheses. If it's three, same idea. A times x plus y plus z. Well, we can extend the distributive property out. Doesn't matter whether it's addition or subtraction. There might be more than two pieces or terms inside the parentheses. But you end up with ax plus ay plus az. Alright, and so here's a visual version of the distributive property. 2 times x plus 3. Well, if you think of this as being like x, and then here's your plus 3, then 2 times all of that would mean you need 2 rectangles, and then 6 little red squares. You might also sort of draw a visual version that doesn't have these little tile-like symbols, and just say, okay, well, 2 times x plus 3. Well, 2 times x is 2x. 2 times 3 is plus 6. And so there's your two good visual reasons why the distributive property works that way. You might remember hearing about FOIL. And FOIL's great if you need FOIL to sort of remember how to do it, but you need to realize it's really just the distributive property. You distribute A to C and D, and that's your F and your O, first, outer. And then you distribute the B to C and D, and that's your inner and your last. So really the FOIL method is just a mnemonic for remembering how to distribute correctly when there are these two pieces. And so I tried to set up another, again, visual version of this. Here's x plus 2, x plus 1. Well, an x times an x is an x squared. 2 times x is 2 x's, so you end up with rectangles. X times 1 is an x, rectangle. And then this 1 and 1 times this 1 would be 2 1s right here. And so you get x squared plus 3x, which are the rectangles, plus 2, which is the little green squares. I don't honestly like this as much as sort of this visual over here, but if this works for you, great. So you could do this differently and still be kind of visual. You would have x plus 2 times x plus 1. Well, x times x is x squared. There's the f. X times 1 would be the O, the outer. would be 1x. The inner would be 2 times x is 2x, and then last would be 2 times 1 makes 2. And then you can combine these like terms to get 3x. So there's your sort of a visual version of FOIL. What if we needed to go even further? And so here we go. We got x plus 3 times 2x squared plus 10x plus 1. Well, how many times would you have to distribute to come up with an answer? And so you would take, they've color coded it for you. You take the red x and you're going to distribute to each of these 3 pieces. You're going to take the green 3 and you're going to distribute it to each of these 3 pieces. And so you've already distributed twice, and then you're going to distribute some more to get the x's moved in and the 3 moved into each of these parentheses, and then you would combine like terms. And so that's kind of the idea. So we need to go and we got to do our examples of distributing. And so maybe you like drawing the arrows, so at least for the first few, I'll kind of draw the arrows still. We want to distribute -5 into 2x minus 7. I don't think very many of you need to show the work of -5 times 2x plus -5 times -7. But I need you to realize that is technically what's happening here. What's -5 times 2x? -10x. -5 times -7 is positive 35, so -10x plus 35. And again, I don't think you actually have to show this step. I think a lot of you do that in your heads. But just since it's our first one together, I thought I would emphasize it to you. So now we're going to distribute 3xy to all 3 of these pieces. Well, 3xy times 2x. Well, 3 times 2 is 6. And then variables wise, we would have xy times x. So that's an x squared y. 3xy times -y. Again, you can make that a -1 if you like. 3 times -1 is -3. So not very good. Let's cut that a little bit. Xy times y would be xy squared. Because remember what the definition of an exponent being 2 is that it's representing something times itself. So on this one we had x times x gets us an x squared. On the other one we had a y times a y gets us a y squared. Cat's always curious what I'm doing up here. 3xy times 4 would make 3 times 4 is 12. No variables involved, but we keep the ones we were distributing. So 12xy. You look over this real quick and you'll realize that none of those are like terms. Alright. X times x. X squared. X times 2 plus 2x. Here we got to be careful. We're going to distribute -5 times x. I'm going to go ahead and line these up. -5x. -5 times 2 will be -10. We need to combine our like terms here in the middle. We get x squared. 2x minus 5x is minus 3x minus 10. And again, if you don't like this, if this does not work for you, then by all means switch and try to use this more like this table. So I'm going to try that version on this other problem so that you can watch that one in action too. First and foremost, how's this one different? Well, it's something squared, so we've got to realize kind of what's going on. Oh yeah, something squared means to take the quantity and multiply it by itself. And we're going to do it using the box method, for lack of a better word. Box method. So since it's something times itself, we would have 2a minus b times 2a minus b. Well, 2a times 2a, let me switch to purple or something, because there's a lot of blue here all of a sudden. So 2a times 2a is 4a squared. 2a times negative b, negative 2ab. Negative b, or opposite of b, times 2a is also negative 2ab. And then negative b, or opposite of b, you want to be technical, this should be opposite of b times opposite of b. Well, negative times negative is a positive, and b times b is b squared. You might be noticing that these two are like terms, so our final answer here is 4a squared minus 4ab plus b squared. When we add these like terms, we get negative 2 plus negative 2 makes negative 4. If you'd rather have done it just with the arrows and sort of writing it all out, go for it. That's fine. We've got two sort of harder ones left. It might bother you. I don't know if you've necessarily seen one before where it's got this problem that looks like the foil problem, and then there's just an extra piece sitting out here on the outside. So what you're going to do is you're going to ignore that, and you're going to work this out, and then you'll take care of the negative 2 that's in the front in this case, or maybe it have been an x. Or for a really tough problem, it might have been even another set of parentheses with something in it. Let's go out to the side here and do a box real quick. X minus 3, times 4x minus 3. So we multiply here, we get 4x squared minus 3x minus 12x, and then negative 3 times negative 3 is positive 9. Oops. And so we can write that this problem becomes negative 2 times, and we're going to replace all of this with what we got over here, and we'll go ahead and combine like terms since we can. So 4x squared minus 15x plus 9. And I would hope that if you tried the problem and made it that far, then you would just distribute the negative 2 and be done. So it'd be negative 8x squared plus 30x minus 18. And that would be it for that problem. I'll point out to you that if you distributed the negative 2 to just one set of parentheses, like the x minus 3, and then took whatever you got from that and foiled it with the 4x minus 3, you would get the same answer. But I've just always felt like students tend to make more mistakes if they do the distributive first. Like a lot of them are real tempted to sort of distribute to everything that's in parentheses, and that's not how the problem works. This one we're going to definitely use the box method on. You could draw the arrows if you like. So, you know, if you get these, you don't need to do this. That's great. But the people that have trouble with these, the box method tends to help. Tends to help keep them organized. They don't miss any of their multiplications. And then they can just kind of look at the box and see what the like terms need to be combined, because they tend to be in diagonals. Not always the case, but they tend to be in diagonals. So x times x squared, we're distributing this x to all three pieces. So this is like the same as drawing all three of those arrows and doing those three multiplications to go and fill this row out of the box. So this would be x cubed minus 2x squared plus 3x. We had an x times 2 x's, that gets us 3 x's total. So x times x squared is x cubed. Multiply each things by 1 is pretty easy. So plus x squared minus 2x plus 3. So there we go. We're ready for final answer time. This is our only x cubed. This would make a grand total of, you owe me an x squared, negative 2 plus 1, You can always write a 1 right there if you want. Negative 2x plus 3x will make plus x. And then that's the only thing that's just a number, so plus 3. And again, that wasn't the only way to work those two, was to use the box method, but the people that have trouble with it, I wanted to show them in the way that I feel like tends to help them the most. So thank you. I'll see you in class. I'll see you on the next video. You should be ready to work with some variables now. We'll use these skills for the remainder of the year.